All right, so today we're going to talk about direct variation. So direct variation is when something varies directly with something else. So a direct variation is going to always pass through the origin when it's graphed, and it's always going to have a slope. The slope of that direct variation is always going to be equal to our constant of proportionality. So when it's graphed, when you have x and y, it's going to pass through your origin, 0, 0, and then look something like this. This would be a direct variation because it passes through my origin and it makes a straight line. It makes a straight line, it passes through the origin, it's a direct variation. So our direct variation equation is y equals kx. So this kind of looks like, in slope-intercept form, it's y equals mx plus b, right? Well, if b was 0, this would be gone, and we would just have y equals mx, but basically it just means it's going to start at 0. So it's like y equals mx plus b, except b is 0. So it's just y equals kx. And k is your slope, but also it's known as your constant of variation. And so the way to find k is to take y divided by x. And we're just using this same equation, and we are solving it for k. So I would take, to get k by itself, y divided by x. All right, so we're going to go through these examples. So identifying direct variation from tables. If y varies directly with x, find the constant of variation and the function rule. So to do this, all I'm going to do is plug in y over x, y over x, y over x, and I'm going to see if they are proportional or equal to each other. So I have 0.5 over 1. That's y over x. And then this one is 1 over 2. And then this one is 1.5 over 3. And I would check and see if those are equal. Well, 0.5 over 1 is the same as just 0.5 or half. This is half, so they're equal to each other. And then 1.5 over 3, well, 1.5 is half of 3. So these are all equal to each other. So I know that, yes, this is a direct variation. And you can, if you aren't sure, cross multiply and set those equal to each other and see if they are equal, and that will tell you if they vary directly. So for example, I could do 0.5 times 2 is equal to 1 times 1. 0.5 times 2 is 1, and 1 times 1 is 1. That should be an equal sign. 1 is 1, so yes, that varies directly. And you could do it this way too. 2 times 1.5 is 3, 1 times 3 is 3, 3 is equal to 3. So yes, this is a direct variation. So then my constant of variation is what these are all equivalent to. They're all equivalent to half. So if I was going to put that into a direct variation equation, the y equals kx, I would plug in half. So y equals half x. I just took y divided by x to figure out my k. And then I plugged it back into that equation. So y equals half x would be my direct variation equation. Let me show you what we've done. So y equals half x. This is when I cross multiply. All good things, all good things. Okay, I'm gonna do the next one. I hope you can see this. Okay, so on this one, I'm going to do the same thing. So y over x, that's 10 over 1, 22 over 2, and 33 over 3. You could really quickly already tell this is 10, 22 divided by 2 is 11, so they're not equal. If I wasn't sure, I could cross multiply. 10 times 2 is 20. 1 times 22 is 22. So those are not equal to each other. So no, it is not a direct variation, so I do not need to find my constant of variation because there isn't one. All right, for these, I'm going to identify direct variation from the equations. So 4y equals 12x. I want this to look like y equals kx. So basically, I just want y by itself. So to get y by itself, I would divide by 4 on both sides, because what you do to one side of the equation, you have to do to the other so that they stay equivalent. So 4 divided by 4 is 1, so I just have y. 12 divided by 4 is 3. So y equals 3x, which means my constant of variation is 3 in this case. I don't feel like you guys can see this super well. So y equals 3x. Okay, so my next one, if I'm trying to get y by itself, I could divide everything by 6. So I'd have y equals 2x plus 3. Well, this doesn't look like y equals kx. It has a plus 3. If I graph this, I would start at 3 and go up 2 over 1. That does not go through the origin, so it's not a direct variation. And if you could tell that before you divided by 6, you don't have to divide by 6 to solve that, because if it has a plus or minus, I automatically know that it's not going to go through the origin, so it's not a direct variation. On my last one, y equals x over 15, this one's kind of confusing because it looks like it's being divided by 15, but I could rewrite that to be y equals 1/15 x, because dividing by 15 and multiplying by 1/15 is actually the same thing. And so if I multiplied like that, then it is a direct variation, because I could just multiply it by 1/15. And so yes, it is a direct variation, and the constant of proportionality is 1/15. All right, we're going to use a proportion to solve a direct variation problem. So suppose y varies directly with x, y equals -4 when x is 25. So if we go back up, we see k equals y over x. So I'm going to be consistent with that and do y over x. And I'm going to make a proportion. So when y is -4, x is 25. And it wants to know what is x when y is 10. I have to stay consistent with my y on top and my x on my bottom. So y is 10. I'm looking for what x would be at that point. And then I'm just going to solve it like a proportion. So with proportions, you can look and see if there's a pattern. I don't see any good pattern from -4 to 10, like to multiply by. So I'm going to cross multiply to solve it. So I have -4x equals 25 times 10. 25 times 10 is 250. And then I would divide by -4. 250 divided by -4 is 62.5. And it's going to be negative, so -62.5. On my next one, the cost of buying peanuts varies directly with the weight. So we'll do cost over weight. Write an equation to model this situation. So it costs $47.50 for 8.5 kilograms. How much for 20 kilograms? So we're going to do $47.60 over 8 5/10. And then we have to stay consistent. We did cost over weight, so we're going to do cost over weight again. So I'm going to do x, because I'm looking for the cost over 20 kilograms. Stay consistent, cost over weight, cost over weight. So then I can cross multiply to solve that. 47.60 times 20 equals 8.5x. So then I would take 47.60, which is 952. And then I would divide it by 8 5/10. divided by 8.5 is 112. So that means it's going to cost $112 for 20 kilograms of peanuts. That's a lot of money to spend on peanuts. All right, our last problems, we're going to graph our direct variation equation. So basically, we're just going to graph these equations. We can do this. So y equals 3x. Oh, I haven't touched a marker. Well, that's like it has a plus 0. So we start at 0. And my slope is 3. So I go up 3 over 1. Up 3 over 1. So on and so forth. And there's my graph. For the next one, write and graph a direct variation equation that passes through the point 310. Well, I know that a direct variation equation has to go through the origin, so I can put a point at 0, 0, and then it says it goes through the point 310. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 310 and put a point, and that would be my graph. It has to go through 0, 0, and it has to go through 310. If I want to figure out my equation, I just need to figure out my slope. So y equals kx, k is my slope. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 3. So y equals 10 over 3x. Or you can think of it as it's always y over x for your direct variation. Well, y is 10 when x is 3, so it's 10 over 3. And you could rewrite that as a mixed number and do y equals 3 1/3 x. You don't have to do that necessarily in this case because sometimes it's easier to have it as a fraction because it's easier to graph. Okay, so those are my graphs. I will upload this document up on Canvas as well, so you can just look at the document and copy them if you didn't get any of these notes as I was talking about them. And then you can do your assignment on the back side of the worksheet that you have. Just copy your assignment into there. And if you have questions, feel free to email me. And we will go through the assignment tomorrow.